Hello, dear friends. This is Dr. Pankaj Nagpure, Associate Professor in Department of Physics, Sri Shivaji Science College, Amravati. I welcome you all into this online course, Physics with Scilab. This course I have designed with the intention to introduce physics and mathematics students to Scilab software, its environment, its capabilities, how it can be effectively used to solve the complex problems in physics. It is not the aim of this first course on Scilab to be an exhaustive and in-depth look of Scilab, but it is an attempt for beginners to start with least complications and aim that anyone wish to start learning to use Scilab entirely by his or her own. This is the tentative day-wise planning for topics to be covered during the course. Some topics may be included during this course as and when it is required. Welcome back, dear friends. In this lecture, first we will see what is Scilab. Scilab is a freely distributed and open source scientific software package for the numerical computations. A powerful open computing environment for engineering and scientific applications. It was developed since 1990 by researchers from INRIA and ENPC. It is now maintained and developed by Scilab Consortium since 2003. From July 2008, it becomes the part of DGTO Foundation. The current version of Scilab is 6.1.0, which was launched on 25th February 2020. Since 1994, it is distributed freely along with the source code through the internet from the website www.scilab.org. Scilab users can develop their own module so that they can solve their particular problems. The Scilab language allows to dynamically compile and link other languages such as Fortran and C. This way, the external libraries can be used as if they were a part of Scilab built-in features. Scilab also interfaces LabVIEW, which is the platform and development environment for a visual programming language from National Instruments. The features of Scilab. Scilab is a high-level programming language due to the open source nature of the software. Some user contributions like defining new data type and operations have been integrated into main program. Using Scilab, many numerical problems may be expressed in a reduced number of code lines as compared to similar using traditional languages such as Fortran, C, or C++. This allows users to rapidly construct model for range of mathematical problems. In other words, we can say that writing syntax for Scilab is easy as compared to the traditional languages. Scilab has integrated object-oriented 2D and 3D graphics with animation, a dedicated editor, an XML-based help system. It has interface with symbolic competition package like Mapper and MUPAG. It has interface with TCL, TK. Scilab can work with most Unix systems, including Linux and on Windows. It's all versions and Mac operating system. Now, toolboxes in Scilab. Scilab can handle linear algebra, sparse matrices, polynomials, and rational functions, 2D and 3D graphics with animation, interpolation and approximations, linear, quadratic, and non-linear optimizations, ordinary differential equation solver, differential algebraic equation solver, differentiable and non-differential optimization, signal processing, statistics, XCOS, which is a hybrid dynamic system modeler and simulator. Scilab is used in many educational institutes, research centers, and industries. Scilab can be used for maths and computation, algorithm development, modeling, simulation, and visualization. It is used for scientific and engineering graphics, can be exported to various formats so that can be included into documents. Now installing the Scilab. As I have told earlier, Scilab is a open source software for the numerical computations that can be freely downloaded from the website www.scilab.org. It is available for Windows operating system, Linux, Mac OS X operating system. In this course, I am using Windows 7 operating system for the demonstration. Now you can pause the video and go to above website and install Scilab 6.1.0 version on your Windows operating system. To launch the Scilab program, double click on the icon Scilab 6.1.0 which is appeared on the desktop. After installing the Scilab on your system, if you don't find the icon on the desktop, go to Start button on the desktop, then go into Programs and then click on the Scilab icon. It will automatically load the tools for managing files, variables, and applications. If you want to end this Scilab session, go to File and click on the Quit option. You can also end the session by simply writing the command quit on the command prompt. When you launch the Scilab, command window appears on the screen called as Scilab Console, which is used for making calculations. Then there is another window which is used to edit, write, or to save the program called as Synodes or editor window. There is separate graphics window for displaying graphics. Graphic window automatically opens when making any plot. There is also an embedded help window that we will see later. First, we will see console or command window. By default, console consists of four sections: Scilab console, file browser, variable browser, and command history. In console, after the prompt or arrow, just type a command and press enter on the keyboard. You will get the result corresponding to your command. If you assign the variable for the operation, then result will be written as the value of the variable. Otherwise, it uses ANS as a default variable. The variable browser allows you to find all variables previously used during the session and their assigned values and types. Command history allows you to find all the commands from the previous session to the current session. The typing directly into console has two disadvantages. It is not possible to save the commands, and it is not easy to edit the multiple lines of instructions. Therefore, when several commands are to be executed, it may be more convenient to write these statements into a file with synodes. To open the synode, click on the first icon in the toolbar or go to Applications on the menu bar and then click on to Synodes. The editor window opens with default file name Untitled 1. In the Synodes, you can write multiple commands and can be executed after saving as SC or SCI extension. This is the help window. To open this help window, click on to the icon of question mark in the toolbar or just type the help at the command prompt. To obtain a list of Scilab functions corresponding to a keyword, the command apropos followed by the keyword should be used. Help can also be from Scilab demonstration. This is available from the console in the menu Help and then Scilab demonstrations. Now customizing the console and synodes. You can customize The font size, colors of the workspaces, that is console or nodes, by clicking preferences on toolbar to adjust the font, go on to fonts and set the fonts for console or node that you like. So we will see some important points to note about Scilab environment. More than one command can be entered on the Scilab console in same line by separating the commands by semicolon or commas. In Scilab, any line which ends with two dots is considered to be start of a new continuation line. Any line which begins with two slashes is considered by Scilab as a comment and it is ignored by the Scilab. Scilab is an interpreted language which implies that there is no need to declare a variable before using it. Variable names that we are using may be as long as user wants, but only first 24 characters are taken into account. Scilab is a case sensitive. Therefore, the capital letter will not be equal to a small letter. In adding a semicolon at the end of command line, the calculation is done but the result is not displayed. It is possible to come back at any moment with the keyboard's arrow keys or with mouse. The left and right keys are used to change the instructions and the up and down keys are used to come back on the previously executed command. So these are arithmetic operations. The plus sign is used for addition operation, minus for subtraction operation, asterisk for multiplication, slash for right division, backslash for left division, then caret symbol for power, double asterisk also can be used for a power operation, single right quote for transpose conjugate, equal to sign for assignment, that is assigning some value to the variable, the predefined variables. The variable names preceded by symbol of percentage are the special variables that are used often and therefore predefined by Scilab. It includes imaginary number, pi, exponential, precision of the Scilab, which is depend on the operating system or the machine you are using, infinity, not a number, polynomial variable, Boolean variables, true and false, built-in functions. There are built-in functions which are commonly used in the mathematical operations like trigonometric functions, arc functions, hyperbolic functions, inverse hyperbolic functions, square root, exponent, sum, minimum or maximum, absolute, sine, real and imaginary part of the complex function, etc. Useful commands in Scilab. General commands. CLOCK clock command used to display the clock in the Scilab, date command to display date as a string, ver is a version command used to display version of Scilab, workspace commands, clc is for clearing the console, clear to remove the variables which are not protected, clear xyz to remove the variables specified in the command, clf clears figure window, diary command is for listing the current session commands, who command gives the list of variables currently in the Scilab workspace, directory commands, pwd present working directory is provided by this command, copy file command copies a file, make directory command makes a new directory or folder in the current. Let's do some hands-on with Scilab. Here I am demonstrating some rules and use of some commands, operations, variables, constants, etc. Let's begin with some important commands. Clock command. Write a clock command in the prompt and enter. It will display complete clock along with date. So presently 25 minutes 41 seconds past 8 a.m. and the date is 14th July 2020. Now next, date command. It will also display the date but in the form of a string. Now version command. Type ver and then enter. So it will show the version of the Scilab using the operating system and other things. Then clc means clear console command, enter. So it will clear all the commands or the contents on the command prompt. Then who command, who, enter. It will list all the predefined variables in the Scilab. clc. Now I want to clear the console. Clear command. So before that, uh, I will assign some values to the variable. Say a equal to 2, b equal to 3. So now if I use the clear command, so then it will erase the values of the variables assigned from the memory. Now if again I use the same variables and if I use the command clear a, then it will erase the assigned value of variable a from the memory. Next I will demonstrate pwd command, present working directory. Enter. So it will display the present working directory. So on the C drive, users, aspired, documents. So this is my present working directory. Now let's try some numerical calculation. First I write addition operation. Suppose before that I will clear the console. So suppose 13 plus 15. So the answer will be 28. If I assign some variable for this addition operation, then the result will be displayed as a value of the variable. And if I write this semicolon, then it will not display the result, but still I want to display it. I use the command disp, then in bracket a, enter. So now it will display the value of a. Some more numerical operations. Suppose I write 6 plus 4 divided by 2. So it is 8. Same numbers if I write like this, then result will be different. So from this you can understand the hierarchy of the operators is similar to that are used in traditional languages like Fortran or C. Now multiplication operation, 35 multiplied by 2. Now our operation, 35 raised to the power. So the caret sign 2, it will give the power of 35. Suppose 4 to the power, we can use double asterisk also for the power. So this is the result for 4 raised to power 3 divided by 2. That is 4 raised to power 3 is 64 and it is divided by 2. Now if we write this like raised to power 3 by 2, then it will display some other result. So in this way you can understand the hierarchy of the operations in the numerical computations. Some more examples I will write here. 4 raised to power 3 by 2 plus 32 raised to power zero point 0.2. So answer is 34. Now I will write this in some different way. 3 by 2 in bracket plus 3 by 2, 32 raised to power zero point 0.2. So the result is different and so on. Now we try some mathematical functions. Before that I will clear the console by the command clc. sine function. So I will write sine of pi by 2. So pi is a predefined variable, and therefore we preceded pi by percentage sign divided by 2. So this will give the value of sine of pi by 2. Now cos of pi by 2. So cos of pi by 2. So percentage pi divided by 2. So this is equal to, okay, this value you can assume to be a 0. Now we write sine inverse of 1 by 2. So this is equal to pi by 6. Then we write some pi by 4 into cos pi by 4. So it will be a zero point 0.5. You can check these answers whether they are right or not. Next function, exponential. So I will write exponential of 2. So it will give the value of e to the power 2. I may write this in the form of variable exponential of x. Now here x was not defined. So first I will define the x. Suppose x is equal to 2, and then I use this function exponential of x. So exponential of x is 7.38905661. Again I will clear the console. I will write now a complex number. So to write the complex number, so 2 is a real part, and now imaginary part, percentage I for imaginary number, and 3. So this is a complex number. Now I assign some variable for this complex number, c. So this complex number c is equal to 2 plus 3i. So if I want to know the real part of the complex number, then the function I write real of c. So it will give the real part of c. If I want to know the imaginary parts, then I will write this function imaginary of c. So it will give the imaginary part of the complex number. Suppose if assign the value to the variable a is -9. So if one to get the absolute value of a, so the command is absolute abs of a. So absolute value of -9 is 9, and suppose I want to know the sign of a, then sign. So sign will be minus. So it is shown by the -1. Now square root. square root. So this is the command for the square root of a. Suppose a is, we have assigned the value for a minus 9, and we take the square root of 9. So its square root is 3i. Okay, so I is imaginary number. So if we write this in the same command in the capital letters, so it will not work, because as I have told earlier that Scilab is a case sensitive. Therefore, for the Scilab, capital letters and small letters are not same. So you should write all the commands in the small letters. Okay, now I clear the console. It will not work because caps lock is on. CLC. Okay. Now double slash. If I write any command after double slash, suppose I write square root of 9, enter, it will not give any result, because double slashes means for Scilab it is comment. That means it is not to be executed. Now if I go on the arrows, if I use upward arrows, so it will move on to the previous used command. Either I can use upward or downward arrows, and right and left arrows can be used to modify the instruction or command. This is all for today's work. You can practice all these things at your Scilab. Tomorrow we will see the vectors, creating the vectors, operation with vectors, matrices, and some matrix operations. Thank you.